Alright, ladies and gentlemen, we meet again. So let us quickly look at this previous question paper again. That was written 16 August 2023. 16 August 2023 of engineering drawing. Engineering drawing N2. I want us to look at question 4. And if I tick them like this, which means question 2 has been already uploaded, question 3 not yet, question 5 already there, question 6 not yet. Vandaag we are going to upload question 4. So this one is there, the solution of this one is there already. So this one is there already, interpenetration. So I want us to quickly look at this one. This one is simple. Okay, so this is there you go. All right, so question 4. Okay, so it is necessary for you to go through the question first, because you might find that the question or the instruction, it would be like, do not attempt question 4, please go to the next page. So it is very much important to read the instruction or the question. So question 4, isometric projection, and it's paying a much 15 marks. You see, it's paying 15 marks. So it reads as follows: figure 4 below shows two views of a machine component drawn in first angle orthographic projection. Do not redraw the given views, but draw the component, draw to scale 1:1 an isometric view of the component. Point P must be the lowest point. So you are expected to show all the construction lines of the cycle, you understand, which is isometric cycle. So it is very much important. So the trick here is actually here. So the rest of the drawing is actually grade 10 stuff, you understand. So guys from TikTok, I'm sorry, some of your comment I might not be able to go through them. I can see you are writing. Please try to answer each other, you understand. So Sahan is saying is civil engineering drawing. No, my brother, this is mechanical engineering drawing. So it is not civil. It is a mechanical engineering drawing. So you understand. So these are the views that were given. So before you even draw, you'll have to analyze those views, you understand. So the question, it has already told you that those two primary views are given in what? In first angle orthographic projection. So you come to them. So you see that you are having what? A symbol. So this is the first angle orthographic projection symbol. So there in first we are having the front and the left and the what? The top. So the word right, we do not talk about it unless it's third angle orthographic projection. So if they are these views are being arranged like this, so which means we can say this is the first, this is the not first, this is the what? This is the front, this is the left view, right? And the point P that they said is supposed to be the lowest point, thereby your front view is on your left hand bottom corner of your view, and thereby your left is right there. So let us start. So you know, in isometric, you'd be always advisable to start your isometric a little bit low, because what you're about to draw is gonna go up, you understand. And I think my drawing is going to fit here. So don't forget about this one. This one is already uploaded there. So right next to this one, I want to put this, you understand, so that I have them in the same drawing sheet. So I'll start with the horizontal constructional line. So this constructional line is out of dimension, you understand, it is out of dimension. Okay, let me position it like this. So now right from there, I'll draw a line that will be perpendicular against it. Perpendicular against it. So which means it must form angle 90, isn't it? So there we go, perpendicular against it. So where they are saying, when they're saying point P must be the lowest point, so that P that they are talking about, where these two lines are perpendicular to each other, so I'll be having that point, I'll give it a name as the P that they are talking about. You understand? So from there, what am I going to do now? So from point P, I'm going to open, take your 30, 60 anti-clockwise and clockwise ruler set square, and draw this point like this is upside down. So I draw it very faint, and this side again, I'll draw it very faint as well. So these lines of mine for now, they are faint, they're supposed to be faint. Okay, so from there I will have to come now to my views. You understand? So this is the left view, this is the front view. So what's going to separate left from front here? This portion, I must have the front view. This portion, I must have a what? A left view. Remember, these are given in what? In first angle orthographic projection. So it is very much important to understand that. It is very much important to understand that what I'm drawing is given in what? In which angle, whether is it first or third. And after you've understood, then you must know how are you going to put your views right here now. Now, not in a Cartesian plane, because like this, we can say there is a Cartesian plane of 4 quadrant. If I can divide this like this, so you see that we at the end we are going to get 4 quadrant, as such that we'll be counting them anti-clockwise, which is first quadrant, second quadrant, third quadrant, and fourth quadrant. You understand? So the views are given in a Cartesian plane, whereby is orthographic projection. But now when it comes to the isometric, the what you call the Cartesian plane thing is not applicable. So somebody might be like, why the front view is on my right hand side, whereas here given in your right hand side? So here we do not have when you analyze them like this, remember that they are given in what? In quadrants, like as I've said. But now the quadrant method or a quadrant scenario here is not applicable. So what I see on my left hand side is what is supposed to be on your left hand side, so that the front view is going to be in your right hand side. If these views were given in third angle orthographic projection, so the front view was going to be positioned this side, so that the right view is going to come to your right hand side. So where I'm explaining the difference of what I'm talking about is just scroll down in one of my videos there by YouTube channel. You will see where I'm throwing a practical example with a block steen, a break. You understand? So now, which means if this is my left, I will force to have a shape like this side. Are we together? And a shape like this side. So if I will do like that, I will be in a right track. So now if the set point P is supposed to be the lowest, that P is now this one. So from point P coming this side, I have a 40. So I will measure, or I'll record the 40 diameter from here coming this side, not from here going this other side. You understand? Because when you come this side, from here coming this side, the dimension that I have to deal with is what? Is 80 millimeter, which is this one from here till there. You understand? So if I want to deal with this 40 from P to coming this side, which means I must come to this side. Why? Because I'm reading or taking that dimension from my left view. So let us do it. 40 millimeter. And I am not going to draw any line yet. Why? Because of from point P till there is no any bottom solid line. Then from where the 40 ends, there is a dimension of 10 millimeter. So from where 40 ends begins 10, from here till there is 10, and I can even draw it dark now, this one, you understand? So from here till there is 10 millimeter. So where my 10 ends, I see a vertical upgoing line with a height of 90 millimeter. You see, both the front and the left, they will always share the same height. The front view and the left view, they will always share the same height. So in case any dimension, as long as it's behaving vertical, I don't see it on this view, I can be able to read it way on the other view, as long as it is behaving vertical. And the top view, which is omitted here, the top view and the front view, they will always share the same what length. And the top view as well as the left view, they will always share the same breadth. Understand? So from here till there is 90 millimeter. So I cannot just record 90 millimeter like this, because what if I'm squeaked, I'm like this or I'm like this. So I have to firstly get a well recorded line faint. Understand? Then from the faint line, I can now be able to record the 90 millimeter that I'm talking about. So there is my 90. My 90 is ending here. I'll give it a mark there, and we are told what this 90 is actually ending here. So from there going up is is 10 millimeter. You understand? So I can record the 10 millimeter again from here to right there. That's the 10. So where my 10 ends, now I can put this line faint at an angle of 30 degrees. Squid. There you go, faint, and angle 30 degrees clockwise, faint. Now together. Then from there, let me see, position this one very well, just zoom it a little bit. Then from there, I'll also have to take what this 90, where my 90 end, take it this side, faint for now. So now it's good as if there by my left view, it's good as if I'm up there at that corner, you understand? So now from this corner, coming back to what my point P is dimension of 50 millimeter. So this 50, I can record it here, it's still on the same thing, even up there, it's still on the same thing, you understand? So since I'm sitting down, let me just record it on this one. So there's my 50. So the 50, remember they said we're using a scale of 1:1, isn't it? So the 50 millimeter. So now from there, it's good as if I'm at that point now. So I can go down with what? With that 10 millimeter, which is what we've already done it. So I can go like this, and I can even draw it dark now. So I can come back here and draw this one dark as well. Drawing at night, you see double lines like this they are actually not allowed. So this one from here till there, dark as well. This paper is keep on shifting. Okay, so now let's see, where are we? So from there till there is the 10 that we got, isn't it? So from here till there, I can now join it without fear or favor. So from here till right there, solid, there you go, and dark like this, and then I can complete it dark as well, from here till right there, dark. So this shape that I see and it's on my left view, it is the one that I am actually forcing it to come clear way there by my left hand side, because this is given in what? In first angle orthographic projection. So right, then I can take this point this side, take this point this side. I can just raise it, this one just a little bit. I don't need it anymore now. Even this one, I don't need it anymore. So take this one, faint for now. There you go. In this one, there you go. Right, so do you see that now I'm going towards my my front view, eh? So that's when I can come to my front view and record the dimension of 80mm. So from here it's 80mm. So my 80 there is my 80 ending. So from there till right there I can draw it dark, and I'll take it up from here till there. So now when I'm drawing this one, it's good as if now there by our front I'm at this point. So these ones is this one, you understand? So I can have it solid here. There you go. And I can close it now, even the side, the top view now. So there you go. So from here till there is dark. So I can now go back to what, to close it. Let me put it like this to close it, even this other side, eh? So from here till right there. Hang on. So this is what I see when I'm standing there by my left view, eh? But then there is something that is happening there. So I cannot be in a hurry to draw this up until I analyze it clearly there by my front view. What is that? Is it a square or it's a circle? The clear understanding, you are getting it right from there by your front view, you understand? There by your front view, which is this one. Guys, I said sorry, I might not be able to see your what to call your charts, because I'm actually concentrating here other than concentrating on the screen. So my brother, this is not grade 12, it's actually grade 11, equivalent to grade 11 isometric cycle, which is simple, straightforward. So it's actually supposed to take us about 15 minutes, but for the sake that I'm drawing what is I'm explaining might take us more than that. Okay, so now let's go back and have a line that's gonna start from here, and this line I will draw it faint for now from here to there, and it's supposed to be off a length, because it's actually existing in my in my front view. It's supposed to be off a length of what, of a length of 80mm. So there it is. Once it gets there, I can project it up, and I'll also draw it faint. Yes, so in the final examination or internal examination, everyone would be expected to at least to reach this extent, you understand, because this is more grade 10, you understand. So where you might start to fumble is where is this stage that we're about to start, but at least everyone would have understood this thing's supposed to be like this, this matching component is supposed to be like this, you understand. So now let's come back to what, right from point P, from here going up, we say dimension of 45mm. Do it 45. There is my 45. This is 40 50, eh? So my 45 I will mark there at 0. Right, once I've marked there by 0, then I'll take, so I'll take this center very faint for now, like this. So please listen very well, because that's where a majority of students they might get lost, you understand. So this center is which one? Is this one, from there till there, you understand? So let's get the vertical one, which means, and do you see that the vertical one is actually dividing the length of our front view is dividing that 80. So we'll come back here to get the half of 80 divided by 2. How much are you getting? So we are getting 40. So there is our 40, you understand? So also take it up vertically. Yeah. So there you go, there you go, there you go. This one, there you go. As a center, I'll draw it a little bit faint, you understand? So from there, so this cylindrical pipe of yours, it has got a certain width, because you see it's actually dimensioned there by your left view, so it's of a width of 40, which is the one that you started with, you understand? So how are you going to get that? So right from this point of yours, you are going to get this line. Excuse me. This line from that center, where these two centers are crossing each other, get this line of yours. So from there till they enter the record the 40 millimeter that they are talking about, which is what is the one that you started with, isn't it? So I'll come back there and say, where is the 40 millimeter there? So the 40 millimeter is actually ending right there. So now let me erase this one before it confuses me. I'll see it later, the time whereby I'll be drawing it solid. Even this one, erase it for now. So from there till there is that 40 millimeter. So where my 40 millimeter end, so I'll take this point vertically. This T-square is good, so I have to be careful, especially with my vertical lines. So from there, you see, it's cute, so push it. There it is, so I can draw the vertical center line. So this line is supposed to be parallel to this one, parallel to this one, parallel to this one, parallel. Actually, all the vertical lines, they're supposed to parallel to each other. So again, remember that from here till there is 40 millimeter, isn't it? So now I'll get the other center line. So from there, there you go, there you go, there you go. Right. So this center line is supposed to be parallel to this one as well. So what I'm gonna do now, I'll start with the Baker cycle. I'll start with the Baker cycle, which is diameter 60. So to draw an isometric cycle of diameter 60, we are going to say 60 divided by 2. How much are you getting? 60 divided by 2, not because of the scale, but because of we are looking for a radius. 60 divided by 2. Take your drawing compass. So if I divide 60 by 2, I supposed to get 30. So you open your drawing compass to 30 millimeter. There it is. After getting a 30, so I can come back here. I place it at this point. I give a mark right there. I also come and give a mark right here, and mark this side, and mark down the side. You understand? So from this point to this side, supposed to be 60. From here till there, supposed to be 60. You understand? So this point, I can give it a name SR, stand for this reference of these points that I've just gotten now. So let me get an exact point even here, so that I don't estimate which is excuse me, is that one. Right, we are going to create a square. So now I come back here and take this point vertically, this one faint, there you go, you push it up until to this point, there you go, right, vertically, isn't it? So you come back here, you project this one a little bit down up until to that point, because from here till there is 30. So I now have this one, then go push it up just a little bit again. So there you go. You see here I almost missed it. It's supposed to be exactly on the point, not something close to by, you understand? It's supposed to be exactly on the point. Because if you are going to be missing some point when you're closing your cycle, you find that it's now not closing. Why? Because of you've been missing points. So YouTube guys, are you still with us? Let me just zoom your camera just a little bit. Okay, let's continue. Then from there we are having 4 points, which is a square that is at an angle of what? Of 30 degrees anti-clockwise, you understand? So I can decide to name this one point 1, point 2, point 3, point 4. So you can actually see that we are having a square. A square it's supposed to have 4 corners, isn't it? So 4 corners. So between point 1 and point 2 I've got a center point. Between point 2 and 3 there is a center point. 3 and 4 center again. 4 back to 1 there is a center. So this center again there are also 4. So I can decide to name this one just a small letter A. The 4 and 3, 3 and 2, I can say this is small letter B. So it is actually becomes simple when you number your work, you understand? Because we answer using lines in a drawing class, but in a maths class we answer using numbers, isn't it? So same applies to this one. We answer using lines, so we get lines from points. So those points, it usually becomes simple when you name them, you understand? So here I'll decide to have a small letter C, here a D. So an A, it's a center point of 1, 2. A B is a center point of 2, 3. A C is a center point of 3, 4. And a D is a center of 4 back to point 1. Are we together? So now we are going to take your 30mm ruler. You join these 2 points. You join these 2 points. Which points are you supposed to join? The points that you're supposed to join are the longest opposite point, you understand? So point 2 and point 4, they are opposite to each other. Point 4 and point 3, they are not opposite to each other, but they are in the same line, you understand? Point 1 and point 2, they are not opposite to each other, but they are also in the same line. Point 4 and point 2, they are opposite each other, but not far away compared to what? To point 1 and point 3. So it says join the 2 longest opposite corner. So here we go. Faint. And when I'm joining these 2 longest opposite corner, do you see that this line of ours is actually passing where our centers are cutting each other, or they are perpendicular to each other at an angle of 30 degrees anti-clockwise, you understand? So now after we join the 2 longest opposite corner, you're gonna join the center point to a corner and a corner point to a center. So I've got some other videos where I'm explaining this thoroughly, you understand? So join, you have to be careful, because if you take it a point right, just not an exact point, just right next to it, when you are now closing your what you call your arcs, it won't be, they're not gonna tally because of what? Of this missing dimension that you've been missing, you understand? So you have to be very careful. There you go. and we join a center point to a corner. Now we have to join a corner point to a center, and these two lines, they're supposed to be parallel to each other.